do it there. All right, looks good. Looks good. All right. Let's see. I'm gonna be so for real, bro. I think I give up, bro. Don't give up, bro. Why are you gonna give up? What's going on? Let's reduce this a little bit. Okay, 0.8. Okay. Alright, so we're back on this project now. I took a little break. Past couple days has been a bit hectic, but it's okay. I just took some time to read more about some stuff, and I came across these instructions. I learned more about them, and I guess we can try and implement them in now. Which we'll see. We have to do the 32-bit version, so we have to do risc-v 32M. The M instructions. Right. Alright. I guess we can start implementing now. Alright, so the first part we need to change is going to be we need to go back into our struct. I think it was in here, or our enum class, not the struct. Enum class, we need to make a new type of instruction, and we'll call it M, which will go for these instructions right here. Okay. And I think we can implement it in here. Yeah, I guess it's called M type, right? Like, but it's not really M type. They're considered R type. They're just different. So I'll just call it M instructions. And just get these set up here. So we have H, HU, HSU. Okay, div. Alright, that should be all the instructions for 32-bit, and then alright, so it's updated in the enum classes, right? Now we need to see what exactly to put. So it should be very similar to the R type instruction. So we have so is it worth it making ones? They're all similar pretty much, but let me see. This one's pretty straightforward. It's similar to the regular R type. It's just multiplying, like just doing an operation on two source registers and storing that in a destination register. What is X? I think I'll try and see what's going on here. It's the register width of the architecture. Okay. I need to look at my main function here, so decided to delete the AI. How come, bro? Was it like too hard to implement? I mean, I guess it was a bit ambitious, but like if you put some time to it, I think you could do it. But it's not needed if you don't want to do that. I think your game will still be pretty good without the AI. Alright, so each instruction differs in format. So like for the case of an R type, we had the name, destination register, and then the source 1, source 2, just like how we have it up here in this. But I want to see if like that would change anything. If we have starting with the R type, they share the exact same instruction format as R type instructions. Okay, so it does cover all of them. So, okay. So, notification on instruction coding. Okay. So it's still... Okay, if it's only in the execute, then it shouldn't matter too much. I can change it up in there, but as long as it's different for the output, we should be fine, right? Well, I guess, yeah, it shows here. It's the description is different. So I guess on the outside it's fine. So I guess we don't really need to store them as a different instruction type. We can just store them here as, just keep this the same. And we'll change it here though. Oh no, we don't need to change it here. We'll just store them under R. So I want to just move these up here instead. Under R type, yeah. These will be better like this. So the AI just said who you're talking to, but I think it knows too much. What do you mean by that? What do you mean by it knows too much? Also, how are you implementing the AI? Like, what are you doing to get that AI inside Roblox? Like, are you training it, or like, are you taking like an API key from an already existing model like Gemini or ChatGPT? If you can even do that in Roblox, I don't know. But how are you doing it? Okay, let's see what went wrong. What's going on? Why is this not? What? What is going on? Okay, this looks like there's some error for that. You're scripting it? Yeah, that might be a bit difficult because you have to actually train it, and it's going to take a lot of power. It might slow your game down a lot, so it's probably better to try and implement it from an already existing one, because training it also takes a lot of data. I don't know if you can do that in Roblox, so I don't know if that's possible, but I guess you could look up how to, if it is possible. I mean, you, like, pretty sure, like, to train it, you'd probably need, like, a neural network or something, because otherwise it's not going to know what to do. Okay. Have our instructions. So now we can actually implement. Do we need to change anything in our decoded instruction? I think everything should say save here. Let's move on to this thing. everything should be the same here. Let's see. Any immediate values? No, no immediate values, so nothing needs to change here. I know, but I am gonna make it work. You could. It's just gonna take a lot of work, so don't get too discouraged and actually just stick with it. And if it ever gets too much, you can always pivot and try and implement an AI elsewhere from different models like Gemini or Claude, ChatGPT. But if you try, I think you could do it. Just don't get discouraged if it doesn't work the first time or the second time. It might take a couple tries, because that kind of stuff needs a lot of data and testing. Okay, so now I think everything is set right. We need to change anything here? No. Okay, so now we just need to implement it here in decolor and actually add the instruction types in here. Yeah, I think I'll add it in the end here. Or we'll move these down. The environment calls will move these down and just implement properly. Or it's fine, we can move it down here. It's easier to work with. It's fine. This is okay. Alright. So let's see. Opcode is that value. See what that value is in hex. Oh, we're going from binary to hex, so we need to actually see the value, which is 33 in hex. So if our opcode is hex 33 and func3 value, we have func7. We have a func7 actually too, so we need to do func7 too. I'd like to see the layout of bits. 1 second. Let's see. risc-v, let's see where. Not here. Oh, here. Yeah, so. No, Control H, Control F. Okay, so. Here's the bits are laid out. Func7 takes out the last 7 bits. Func3 and opcode are as usual, and it looks to be pretty good still. And let's take, like, for example, an add instruction. Not atomic, add. Let's do XOR. It'll be easier to find. XOR. Yeah, they have the same layout. I'll make 3 or more scripts for it to be an AI, so it'll not be one big script. Yeah. I guess I might think you might need more scripts. Like, how will those 3 scripts be managed? Like, what are they gonna do? What is each script gonna do? Okay. So yeah, so it's the same, so won't be a problem here. Func3 is gonna be a 0 for the first one, so it's 0. And then func7, which is gonna be 1. So if that's the case, we will get, let's just go up here to our the instructions here, like add, and copy this. It's essentially the same. It will mimic that same pattern, but just change the name, so we'll instead. And it would be an R-type instruction, so it would be that. One for connecting to a rig, one to talk, and one for data store, memory storage. Yeah. That seems pretty good. The data store is probably going to be a long one, though. Longer script than the other two. Yeah, because if you want like an AI that wants to memory, you need to have at least a small little memory window, small context window. Okay. Let's just see if we got everything. So that should be right. And then it'd be the same for the rest of the instructions. It would follow the same format. Mul H, which follows the same opcode, but the func3 is different, and the func7 is the same. So now it's just changing all these values. Pretty simple, and then we can see where to go. Hey, what's up, Moose? Or Mus? How you doing? Okay. Alright, where was I? Mul HU. Mul half unsigned, upper half unsigned. Did we not include that in to our thing? Oh, I wrote the same one twice. We'll probably be able to build and repair things that are bugged in the game. Maybe that's gonna be a lot of work though, not gonna lie. Because it has to analyze your scripts and analyze what's going wrong. And it has to be able to understand what the proper fix would be. So like the data, you'd have to take it from like websites or other places where the AI can actually like reference to know what the fix would be. That's why I feel like maybe using an API is easier, like connecting from RE Gemini, so you don't have to do all that extra data. I mean, I think easily, like, trying to implement an AI would probably at least take probably up to a year or longer, depending on how much you actually need it to do. Because all the research and all the implementation, trial and error, like it's probably gonna take a lot longer than you think it might. So just letting you know there's that trade-off you need to consider. Wait, I did not change this one, that's my bad. Okay, so 0, 0. This one will be 3. From all HE will be 3. And the same with that, and it should be fine. This one is the next one, which will be Mul H, signed and unsigned. So you're doing a signed multiplying the unsigned number, which will be func2, func3 of 2. Okay. And next. I know, but I will try impossible scripting. Yeah, I mean, it's good to try. I mean, you'll build a lot of knowledge trying to do it, so. It probably helps you out in your scripting in the long term if you try. Okay. Next part was, oh yeah. This one would be 4, I believe, yeah, 4. Just div, right? Yeah, div, divide. And it will follow the same format. Next, divide unsigned. And what was the func3 again? That was 4 for divide unsigned is 5. Same for that. 5 side on sign, I'm pretty sure. No. Remainder. And for the remainder, we have 6. Then we remainder unsigned. And remainder unsigned will take 7. 7 has the value. Okay. So I think all these are done now. I will put this in Claude. Just get a quick okay and move on. I will work now and see what happens. Good luck, man. Good luck. Wait. Mul sh. Yeah, HSU. Wait. No, it should be 2. Claude, you're wrong. I think. Let's just go through it again. Choose 3. Choose 3. Oh, wait, never mind. He's not wrong. I made a mistake. I'm sorry, Claude. I didn't mean to insult you. Alright. Okay. Alright, so that's done. We need to now move on to actually implementation in our interpreter now. So that was just our decoder. We need to actually do the memory instructions now. So we will do that right now. I guess we can copy kinda. Actually, no, we don't want to copy because it might be different. So case instruction. And we're gonna start with Mul and implement the case. Let's get this back. Okay, so let's see what we need first. So going back in here. So we're writing to the register, and it would be destination register, and then rs1 plus rs2. So it's done rs1. So reading the register value of rs2, and let's make that in full parentheses around so it doesn't get confused with precedence, and it should be good here. Sorry, I forgot one thing. Of course, we want a break statement here. I don't know why it's typing. Okay, so what else? I think that should be it. Let's reference the other ones up here and see if we missed anything. So, yeah, other ones basically have the same exact format. Yeah, should be fine. Well, I guess there's not really an issue with precedence here, so we don't really need the extra parentheses. Doesn't really matter. pointer. I want that to be like that. Probably not going to be able to work on anything, but let's see what I can do real quick. Alright, man. Why won't you be able to work on anything? Okay, so it's not only it's more H. In the case of that one, it will be okay. Now here's where the xlen matters. So, what did they say xlen was again? Sure, ways of the architecture, okay. Because 64 being the full multiplication result is 64 bits wide when you multiply to, so we go up to 64 bits. The instruction is different, have their turn. Okay. So the lower bits are fine on this case. But in this case, we want a shift of a certain amount because the values are okay. Let me give it a try. Okay, so turns out over 32 bits. When you multiply two 32-bit instructions together, the result can be up to 64 bits. Right. The result can be up to 64 bits. We need to. This is signed and unsigned, so we need to do a signed version of it's 64 for t. Right. And set that the value of. So what exactly are we doing here? So we're reading the register for that same values, right? So we're reading the register for these values first. So that's the first thing that happens. So it's just basically the same thing as, we can just copy here. It's the same thing that goes on there first. Next. So you have a shop, NPC money system, display player card done now. I need to do some other little things in your DMs if you want to look. Alright, I'll take a look soon. It seems like you have a couple of features done, yeah. What about like the main game system, like the main system of the game itself? You said it was like something similar to Among Us, but a couple other features. What about that main game system? Okay, so we have that part done, right? What exactly do we need? So we have 64-bit integer, but we need to actually like first convert this into a 32-bit integer first, because we actually need these values. Because these values will be 32-bit integers first. But on top of that is where we need to convert it back to 64-bit integer which will then cause the upper bit to be a bit different. So we still need to write the register as usual. It'll just be you have no idea what the game is? You might want to figure that one out, because that's the main thing, right? The features are just add-ons. You always start by doing the base game first. You can keep these features, of course, but start with the base game and get the base game done. Then add your features after. Whatever you get in ideas. And make sure you take that slow. Like, just take a feature at a time. Just don't try to do it all at once. Just take one feature. Like if you're doing Among Us, right? Just take like the emergency meeting feature and try and get that done. Get the map done and all that stuff. You can get the emergency meeting feature done, then you can move on to some crewmate tasks, stuff like that, and just implement it in your version. Just don't try to do too much at once. That's why the AI might be a bit too much if you're doing that, and also that. So just make sure you manage your time well, manage your tasks well. Okay, so we're still reading it, but we need to actually do a shift, right? So how do we... Okay, I guess let me give it a try here. So 64. No, it would be a 32-bit. Never mind, you got one. Got an idea? Alright, so this one let's call it upper end. Let's just shift the bits. So since this instruction occupies the upper bits, we need to do a right shift of 32 on result. So right shift of 32, and then in here taking upper, I'm pretty sure. Okay, so this first multiplies the registers, stores it in a 32-bit integer, converts that to the 64-bit integer version, which will have the upper bits occupied, which we are then shifting to the right 32. So it becomes a 32-bit unsigned. Or would it be 60? I mean, I think it's 32, because we have to make sure it's 32 at the end. I think this is fine, but let's just ask Claude. Cas isn't quite right. Look at this line. You're casting RS1 to int 32-bit, but RS2 stays unsigned int. Right. Okay, also you do it for this one too. Okay. So in this case, we're doing that. Oh, we need to cast before multiplication, so... Okay, I guess that makes sense, because... Oh yeah, if you multiply before, it's just gonna be left without the bits actually multiplying properly, so we need to actually do it before the multiplication. So we need to do 2 cas. Okay, so we need to move this. It's a bit confusing to think about, not gonna lie, but I think it's fine. So this first. Yeah, Casey Mans, I'm back. It was just a hectic couple of days, so. But but hopefully I can stream regularly. And also, like, I was just learning, trying to learn as much as I can before getting back. So it should be this. Wait, we did too much, I think. Okay, so it always gets so difficult to know the parentheses. Okay, so 2 parentheses here, 2 parentheses here, and then the outer for that. Okay, I think that's fine. Right now I'm just implementing. So we have all these done, of course, for my interpreter and my decoder. I wanted to get into these ones, the multiplication and division, remainder, because I learned about them recently, so I'm trying to implement them. Okay. I think this is good. Okay, so let's see what those casts are like. Up here. Okay, we can actually read like what's going on. Must be Wizard C++ and Magic Units now, bro. I still have a lot to learn for C++. I'm just doing what I can. Mostly, like, all of it comes from this assembly manual. C++, like, I can still improve a lot of this code probably to make it better, which I will eventually, but I just have to make sure the logic works first. Rewrites come later. You're always gonna write a bad implementation the first time. It's the rewrites that matter after to improve. Okay, let's move on to the next one. So for the case, let's just copy. Okay, for this case, our next case will be half unsigned. So it's multiplying 2 unsigned values. In this case, it was multiplying a signed and an unsigned value, but this case, it's multiplying just unsigned values. No, this case was both signed, both unsigned, and this one will be 1 signed, 1 unsigned. Yeah, okay, so that makes sense. All right, so unsigned version. So it's actually just, it's pretty similar to other one, just change everything to unsigned. It should just be that. I don't see any other like shifts we need for that. And for the case of, let's see if we got everything right. Unsigned, unsigned, unsigned. Okay. And for this one, is it SHU or HSU? HSU, okay. HSU. For the case of that one, it's gonna be the first value is signed, I believe. First value is signed, signed register source 1, and then unsigned source register 2. So these will stay signed. We just need to make these unsigned. But I think we do store the ending value of these two as signed, because if you multiply signed by unsigned, what does that do? Does that just change the unsigned to a signed at the end? Like, what should this be? I think it stays signed. Actually not sure if it stays signed or if that moves unsigned. I think it just should stay signed. And then let's see, the shift is going to be the same essentially. So let's see. Let's see if we hit the nail on the coffin here, or if we mess it up. As a type mismatch, multiplying in 64 by C++ will implicitly convert the into on which breaks down behavior. How come though? Sign extended to in64. Rs2 0 extended to in64. I mean, wouldn't this essentially then mean that it's the same as mul if it's not? I mean, mul h. Which is the result type, not the operand types. Oh, so that's what happens. Okay, so it doesn't promote it to signed, it promotes it to unsigned. So if you do an implicit type conversion like that. Oh, wait. I see what they mean. Okay, so only this value in here is unsigned, but the result has to be assigned as usual. We have to change it back to signed, but it will keep all its unsigned values. The problem is if we had it'd only be bad if we had like this, because then we'd lose some values. But this is perfectly safe. Okay, that makes sense now. Okay, no, I get it. Okay, I get it. Let's just make sure. So you have that, outside int, yeah. Okay, that makes sense to me now. Now we can do the case of division. Alright, so division is, okay. It's a bit more to implement here, so let's see. So we have a destination register as usual. Rs1 and Rs2 are signed, okay. Quotient of a signed division with overflow is equal to the dividend. Okay. Okay, so we'd be dividing the first register source 1 and register source 2. If our register source 2, which would be our denominator, if that's 0, we get like a division by 0 error. When did you start learning C++? Like a month ago. Nah, I don't go to Cornell. This is I wish, but this is just the manual for risc-v. I just found this is the first one I found out. But it would be nice if I went to Cornell. I just go to some state college, so. They have like this page accessible to anyone, so I just use it because it's all laid out here for me, easy to see, so it's much easier for me to reference. And yeah, CPP, I just started learning a month ago using this website here, Learn CPP, and some YouTube videos. I'd say the best way to do it is to go through this slowly. You don't have to rush through this, but like use YouTube videos to get like the main concept, like vectors and structs and object-oriented programming, because like those are pretty late in here. Like pointers and stuff come in chapter 12. It's gonna take a while, so at least you can watch YouTube videos on stuff like pointers and OOP and vectors, but once you get to it, you can actually read in depth on what they are exactly. So yeah, this is a lot. Like it's probably gonna take a little while, but like yeah, this one I go through slowly, but I did all the main concepts out of the way first so I can actually build stuff. This is just like supplemental knowledge to actually learn more about stuff. Took a C course in college. Nice, man. Nice. For mine, we just have Python. We don't have C. I don't know why. They should do a C course, but they're not. My college is just Python. Okay, so yeah, let's get the part done. Okay, so it's gonna be the same thing. So we're essentially writing to a register again, which will take that, and now we can actually get the. For now, I'll just say this. For now, we need to actually write the logic for that. So, which major are you doing? I'm doing information technology. Okay. Alright, so this will be signed, so signed value. Not 32-bit. 32-bit signed. And we'll take in. Or actually, no, we need to make the if statement. We need to make an if statement here. Or probably better do a ternary. So inst rs2, if inst rs2 is equal to 0, make it -1, make the value -1, or divide the two values. So numerator divided by denominator as usual. So it should be good. Let's just always make sure to use parentheses for precedence, just to make sure. Okay, so it should be good. I think that mimics it well. I would like to know why they put it as -1 though. Is that like an assembly thing? And then store that in a variable. You can just call it result, as usual. I think I'll check this real quick. Why do people use Visual Studio Community as opposed to VS Code? I don't know, it's just a personal preference because it has like direct support for C++ here in Visual Studio Code. So, I mean in Visual Studio, not Visual Studio Code. In VS Code you need to install some stuff, I'm pretty sure, to get like some dependencies. But this IDE is made like specifically for like C++ and other programs like that. So it has like direct support for stuff you need to do. Yeah, wait. Go back up there. Oh yeah, I forgot read reg, my bad. Can't believe I forgot that out of all things. Okay. What else? Missing. Oh, dude, I'm missing like simple things, dude. Break as usual. But everything else is good. Like the logic is good. Yeah, it seems like I just made some silly mistakes. The logic is fine. Divide -1 for division by 0 gets us to risc-v spec requirement. The spec defines specific behavior for exceptional cases rather than leaving it undefined. Result is -1. All bits set to 1, which is hex FFFF that. overflow case dividing the most negative number by -1. Result is the most negative number by itself. So, okay. Interesting. So hardware exceptions for integer division by 0. Alright, yeah, we can write the rest of them. Then probably end the stream. After we make sure it's good. I wonder what I'm gonna do for tomorrow though. Maybe we'll start like a new path tomorrow on this project. We have the decoder and interpreter. We can probably add some more stuff. We'll see. I'll worry about tomorrow. Alright, let's write the rest, the cases. KZ Mans, if you're still here, what do you do? What are you working on right now, KZ Mans? Alright, so div unsigned. Essentially the same thing, but it's just unsigned, so all we need to do is change the ending result. That's pretty simple for that. Next is remainder, right? Yeah, remainder. What changes for that? Trying to learn about BJTs. What is BJTs? Catching up with classes right now. Nice. Bipolar junction transistor, that sounds pretty hard. What topic is that for? Like, what class? Okay, alright, remainder signed. It's the same, but it's just a modulus operator instead here. That makes sense because you're just getting the remainder, so essentially the same logic as division, just getting the modulus. In this case, it's not -1 here, but it's gonna be the RS1 value. Okay, wait, let's see. That kind of makes sense. If you have like 5 divided by 0, in this case, they're just taking 5 and making that the remainder. Okay, that's interesting. That's an interesting approach, assembly. So in this case, I really want to see how far this project can go before I start getting really out of it. Because right now I'm kind of breezing through. But I have a feeling this project is going to get really hard at some point. I mean, man, if you gave me this project to work on like 3 weeks ago, if you had me read this, I would not know what is going on. But after you understand like simple assembly stuff, you understand what's going on, you can write it simply. Right now it's pretty simple. Like, this is just decoding assembly instructions, so depending on a bit string, that's a decoder, and the interpreter actually simulates memory, so it actually simulates an ALU, arithmetic logic unit, and all the other stuff in memory, and then actually puts these instructions to registers and simulates memory in that way. Which seems hard, but if you actually like, you can do it and you'll understand it within a couple weeks. But I know it's gonna get hard after a while. Once I start actually going into much more difficult stuff with memory. Right now it's pretty surface level. Yeah, that is my name, yeah. I assume you checked the GitHub or something to find that. The GitHub I put in my description. Okay, and this one would be the modulus, yes. And Same thing for the review. Yeah, I am, but I don't actually speak it. It's been so long since I've spoken it, so I ended up forgetting it. I can understand it, but I can't understand if it's spoken to me, but I can't read it or can't speak it, which is sad. Yeah, it's on my GitHub, yeah. The question unsigned. So it's just here's signed and then the ending block is unsigned. Yeah, reading is kind of hard. Like if you're not actively like studying it or like using it, you're not gonna forget it eventually. The reason we actually like remember English is because we text every day and write stuff every day, so we actually remember it. And everything else looks the same. So yeah, remainder instructions should be pretty good here. And then these we're not going to get into, that's 64-bit. Eventually I might have to switch to 64. I'm just doing the 32 one first. Because realistically, I don't think there's many 32-bit nowadays, to be honest. Most people use 64-bit, so eventually we'll get there. I mean, it's pretty simple to implement 64-bit. It's just a wider range of values for the instructions. Okay, all three. Zero check, same bug as before. It's register a number, not the value. But did I not do the read reg? I keep forgetting to do the read reg. I don't know what's wrong with me today. Making really silly mistakes. Okay, should all be good. And missing sign cast. Signed remainders need the same cast pattern as div. I never had a sign cast for div though. It's not 0 though. I do have the overflow case. I do have the overflow case here. If it's wrong, I might have to check. Like, it should be right. I followed it to a T here. What? Okay, if it's equal to 0, make it rs1, else rs1 modulus that, but for RAM the specs as overflow case, yes, most negative number 0, but let's take a look at another source. Oh, there's two cases. Okay, why didn't... Bro, Cambridge sometimes it gets shit wrong here. Or Cornell, not Cambridge. Cornell gets it wrong sometimes. Earlier they got like one of the opcodes wrong, I'm pretty sure, and now they got this wrong. Okay, appreciate it, Claude. So there's two cases which I didn't realize, which we'll do right now. So we can't do a ternary anymore. We need to actually do it properly. We'll just have it as a reference though. For the next statement. So if what's the cases again? If division by 0, so if our read reg is to value wait, no, sorry, is equal to 0, the remainder will be R1, so my bad, I don't know what's going on. Okay, so first one, we have else if division overflow, only RS1 is I can't read that, so actually maybe we can go back. X1 would be 32, so 32 minus 1, so 31 to the negative 2 to the power of 31, which I don't know, so we're just gonna go back here. Okay, he just gave the value here. Let's just check though. So that is the most negative value you can have, which would be negative of this. Or wait, it wouldn't be. Yeah, it would be okay. Something like this, almost. Oh wait, we can just do that. We can just do in 32 minutes. I forgot about that. And okay, he's making it easier to read. I think my version is kind of hard to read, so we will make it easier to read by making the variables themselves. I was thinking about it. I was like, should I? Makes sense though. And the dividend, I always get mixed up between dividend and so dividend is the numerator, divisor is the denominator. Okay. Wait. And we got reg. And that way it will make it easier to read this statement here. This will be divisor. Dividend. Oh, sorry. If our dividend and okay, so yeah. So if our RS1 value is the most negative value we can have, which we can do by saying int 32 underscore min, right? Yes. And our divisor is -1, I believe, or 0. It was 0, right? -1, -1. In the case of that, a remainder is 0. Then our else case, which will be if everything's normal, we can just divide and get the modulus from that. So dividend results will be equal to our dividend, the remainder of that, and our divisor. Okay. And let's get rid of this and instantiate result as just a 0 initialization of that. Yeah, good thing I caught that for a second. I was looking, I was like, he's making all the values signed. Because the end will always be unsigned that we need. Unsigned. That's why we needed the cast here to first do the operation on the signed and then turn it back to signed, unsigned after. So I think that's right. Wait, let's see. If divided 0 equals dividend, else if dividend equals itmin, divisor is equal to -1, and result would be 0. Yes, else result equals dividend divisor. I was like, okay, so I think that's right. But now I think it should just be unsigned all around the board. But in this case here, we would need the cast here though. I always get kind of confused in the casts, not gonna lie. Casts are kind of confusing sometimes on what we're actually getting. Okay, so we just don't need the unsigned part here at all. Because it's operating on signed, so we don't need to actually store it back to unsigned. Okay. It makes sense now, kind of. Like, I understand the logic. The signed, yeah, I guess it makes sense. The conversions and the storing of those. at the end, static casting. Wait, what the? There we go. Okay. I think all the logic's done here. Nothing needs to be changed with the memory or anything. I believe nothing needs to be changed with that part. So our core processing doesn't need to be redone, or memory. I think it should do it properly there. And we covered every single instruction for those two. Alright, this took a bit longer than I thought, not gonna lie, to get all this. It was a bit confusing with all this stuff here, extra stuff. But we did eventually get it. And yeah, I think it'd be too much to try and implement something new, so I guess we'll end the stream there. So yeah, hope you guys enjoyed, and I'll see you guys tomorrow. And I'll make sure to stream tomorrow. I won't like skip a couple of days, so yeah. Alright, see you guys.